And finally, multiplication. So in the book I already read, the Mystery Math, a first book of algebra, I found a couple of examples of multiplication, mostly the relationship between multiplication and division, since this is a algebra book. However, I thought this one was pretty cool, so I thought I'd read this. Here's what Billy wrote. Z over 4 equals 5. Z is the number of skeletons in the haunted house. 4 is the number of rooms in the house. 5 is the number of skeletons in each room. In the equation Z over 4 equals 5, Z over 4 means that Z is divided by 4. To find the value of Z, you want to get it alone on one side of the equal sign. You can do that by multiplying each side of the equation by 4. Z over 4 multiplied by 4 equals 5 multiplied by 4. Z multiplied by 4 is Z4. So 4Z over 4 equals 20. 1Z equals 20. Z equals 20. There are 20 skeletons in the house. And then my final book, and this is also a really awesome book that I plan on buying, is called Multiplication Master, and this is by Lisa Arias, I believe is how you pronounce it. So many cool things in here. A lot of things that we talked about in our class. So this one teaches not only area multiplication, but it also talks about the commutative property of multiplication. So it says, the commutative property of multiplication lets you switch the order of the factors without changing the product. 3 times 4 equals 12, and 4 times 3 equals 12. So we can see right here, here's our area model. 3 times 4 is the same as 4 times 3, and the product is both 12. So here's another one. This one is a demonstration of the identity property. And it says, time for some fun and multiply by 1. Any factor multiplied by 1 equals that number. This is always true thanks to the multiplication property of one rule. So it shows them a couple of different examples of problems, and we can see that anything multiplied by 1 is itself. Repeated addition is also in this book, and it says multiply by 4. Now that you know your 2 is multiplying by 4 won't be a bore. Just double the factor being multiplied by 4, not once but twice. And we can see that they have broken down 4 times 3 into 3 plus 3 plus 3 plus 3, which you could also do 6 plus 6, and they can see that it's 12. So it also kind of demonstrates that decomposing of numbers, and I just think it's a really cool way of teaching it. So there's another example. And then we've got our number line. So multiplying on a number line. And they called it multiplying by skip counting. Multiply by 5. Let's dive into multiplying by 5. Skip counting by 5 is easy too. Just skip count by 5, count every fifth number. Once you get started, you'll discover a pattern or two. 5, 10, 15, 20. We can see that 5 times 4 is 20. This one was kind of an example. I didn't really say this, but it's properties of 10. So multiplying by 10, they would be able to see the pattern that we multiply the first number and add a 0. And it says multiplying by 10 is easy as pie, just add a 0 to the factor. Come on, let's give it a try. And I was really impressed by this. They actually have an example of the distributive property. I know as a child, I don't remember being exposed to this, and I think it would have helped me, so I really like this. I think it's pretty cool. So it says distribute, multiplying by 12. You will soon see that the key to multiplying by 12 is the distributive property. It's really cool to split 12 up into groups of 10 and 2. Add those facts and you are through. So it shows them that 3 times 12 equals 36 is the same as 3 times 10, which is 30, and 3 times 2, which is 6. And if I add 3 and 6 together, it is 36. So then it also shows them over here, like a more abstract way, this is more pictorial over here, that we can take 3 times 12 and break it into 3 times 10 plus 2, and that would give us 30 plus 6 equals 36. Again, this is such a cool book. I really think that I'm going to buy it to teach math in the future. So that's it.